Welcome back to The Explainer. Today, we're shining a spotlight on the absolute, undisputed engine of web interactivity, and that is JavaScript. If you've ever wondered how modern websites transform from, just static walls of text into dynamic, living applications, well, you're in the right place. We're going to unpack exactly what JavaScript is, what it definitely isn't, and how it fits into the broader digital ecosystem. We'll be exploring the underlying architecture of the web, breaking down the specific technical distinctions that give this language its totally unique and, honestly, sometimes misunderstood power.
Okay, let's dive into this. Here is our roadmap for today. First, the three web pillars. Then, scripting versus system languages. After that, client versus server. Then we'll cover building responsibly, and finally, we're going to tackle the Java myth.
All right, starting things off with Section 1, the three web pillars, and structuring the modern web.
So, every modern web page divides its labor to maintain a really clean, modular architecture. It's kind of like building a house. First, you have HTML, which provides the core structural skeleton via tags. It defines what the content literally is. Next, CSS steps in as the presentation layer. It handles the layouts, the typography, the colors, basically the overall design aesthetics. But here's the thing, a site built with only HTML and CSS is essentially just a static document. It might look absolutely beautiful, but it can't respond to you in real time. That is where JavaScript steps in as the absolutely crucial third pillar. It serves as the behavior engine. It's the logical layer that drives actual interactivity by directly interfacing with the document object model or DOM of the page.
Take a dynamic photo gallery, for instance. You know the ones. You click a thumbnail and it smoothly expands to fill your screen, then you click away and it gracefully zooms right back down to its original spot in the grid. That real-time, seamless response to your action doesn't require reloading the entire web page. No way! Instead, that is JavaScript directly manipulating the DOM on the fly. It actively listens for that click event, calculates the geometry changes needed, and triggers the animation, with the whole shebang happening instantaneously right there within the browser environment. Moving right along to Section 2, scripting versus system languages, and why an intentional limitation is actually a good thing.
Now, JavaScript is officially classified as a scripting language, and because of that, traditional programmers sometimes tend to dismiss it, especially when comparing it to heavy-duty system languages like C++, Java, or Python. And look, it's true. System languages are incredibly powerful. They can freely communicate with a computer's deep architecture, write directly to file systems, query local databases, and manage memory allocation. JavaScript absolutely cannot do any of those things. But that limitation isn't a flaw. It's actually a vital security feature. Just think about it for a second. Every single time you visit a new website, your browser is downloading and executing code written by a complete stranger. If JavaScript had the same system-level access as, say, Python or C++, a malicious website could easily read your private files or literally delete your hard drive. By operating inside a highly restricted sandbox, JavaScript safely adds all that complex interactivity without exposing your local machine to unacceptable risks. It is purpose-built for its environment.
Which brings us to Section 3, client-side versus server-side. Where does this code actually live?
Let's trace what happens during a standard URL request. When you visit a website, a remote server processes your request, gathers up the necessary HTML, CSS, and JavaScript, and then shoots that whole package back over the network to you. JavaScript is what we call a client-side language. That means its execution happens locally, right inside your web browser, using your computer's own processing power. This is a fundamental difference from server-side languages like PHP, Ruby on Rails, or ASP.NET. Those languages execute all their logic remotely on the server, doing things like handling database queries, user authentication, and business logic. Then, they just send the finished, static HTML display back to your machine. JavaScript's local execution is essentially the secret to its speed. Because the code is already sitting right there on your device, it doesn't need to make a slow, round-trip network request to a remote server just to open a simple drop-down menu or validate a password field. It happens instantly, creating a really fluid user experience.
All right, on to Section 4, building responsibly with JavaScript, also known as the accessibility rule.
So because JavaScript runs entirely on the client side, it introduces a pretty unique vulnerability. What happens if the user's browser fails to execute it? Maybe they're on a super slow network and the script just times out. Or perhaps an aggressive ad blocker mistakenly blocks the file. Or, hey, the user might just have JavaScript completely disabled for security reasons. Imagine trying to use an online store where you simply cannot add an item to your shopping basket because that core fundamental action relies entirely on a client-side script that failed to load. Relying exclusively on JavaScript for fundamental site operations creates a super fragile user experience and literally locks people out.
That's why the goal in web development should always be progressive enhancement. There's this great old developer adage that says, add JavaScript to give it that magic touch. A truly robust website needs to be built on a solid foundation of HTML and CSS, ensuring that the essential plumbing, navigating pages, reading content, submitting forms, works entirely on its own. Only after that baseline functionality is totally guaranteed do you sprinkle the JavaScript on top. It should act as an enhancement to streamline the experience, definitely not as a critical crutch holding the entire application together.
And finally, Section 5, debunking the Java myth and clearing up the confusion.
JavaScript and Java. They sound like they should be closely related, right? Like maybe one is just a lightweight, web-friendly version of the other. Well, actually, scratch that. In reality, they are completely separate, entirely different programming languages. They have totally different syntaxes, different use cases, and totally different underlying philosophies. So why the remarkably similar name? Honestly, it comes down to pure 1990s marketing. Back during JavaScript's inception at Netscape, Java was riding this massive wave of industry hype as the next big thing in computing. So the creators of JavaScript simply jumped on the bandwagon. They adopted a similar name just to capture some of that momentum and media attention.
So the crucial point is, the actual, official technical specification for the language is ECMAScript. That is its true identity, standardized by the European Computer Manufacturers Association to ensure it works consistently across all web browsers. But that original marketing trick worked so flawlessly, and the moniker stuck so incredibly hard in the cultural zeitgeist that the entire world universally refers to it as JavaScript.
And there you have it. We've mapped out the foundational web pillars. We've uncovered exactly why JavaScript's strict, sandbox limits as a local client-side scripting language actually make it the perfect, secure tool for the browser. And, for sure, we severed that false link to Java. You now have a really clear, technical view of this incredibly resilient technology and how it fundamentally differs from server-side and system-level languages. The browser is a powerful environment, and it is yours to command. So, now that you know the engine driving the modern web, what kind of magic will you build? Thanks so much for joining me today, and I'll catch you in our next explainer.